Imagine a towel that can absorb over 17 times its weight in water, a phenomenon known as superabsorbency. This extraordinary ability is a result of the towel's unique texture and material composition, making it a staple in kitchens and bathrooms worldwide. But have you ever stopped to think about the underlying mathematical patterns that govern this phenomenon? It all starts with the towel's fibers, which are designed to attract and retain moisture through capillary action. As the towel absorbs water, the fibers swell and expand, creating a network of microchannels that facilitate rapid water uptake. But that's not the strangest part. The towel's absorbency is not just a result of its material properties, but also its intricate geometric structure. The fibers are arranged in a specific pattern, creating a fractal-like design that maximizes the surface area of the towel. This fractal pattern is a perfect example of self-similarity, where the same pattern repeats at different scales. In fact, the towel's absorbency can be modeled using the laws of fractal geometry, which describe the scaling behavior of complex systems. But what does this mean in practical terms? For instance, the towel's absorbency can be tailored to specific applications, such as sports towels or cleaning rags. This arrangement, optimal such as high-temperature absorbency and durability. And then something unexpected happened. Researchers discovered that the towel's absorbency can also be influenced by external factors, such as temperature and humidity. Performance can be optimized for different environments, such as temperature and humidity. The implications of this discovery are far-reaching, with potential applications in fields such as textiles, materials science, and even medicine. For example, researchers are exploring the use of superabsorbent materials in wound dressings and implants. By harnessing the power of fractal geometry and mathematical modeling, scientists can design and engineer materials with unprecedented properties. And it all starts with a simple towel, a ubiquitous object that we often take for granted. But as we've seen, the towel's absorbency is a complex phenomenon governed by intricate mathematical patterns and principles. So the next time you grab a towel, remember the incredible science and math that goes into making it work its magic. In fact, the towel's absorbency can be thought of as a real-world example of the Mandelbrot set, a famous fractal that exhibits self-similarity at different scales. The Mandelbrot set is a mathematical object that has captivated scientists and artists alike, and its connection to the towel's absorbency is a fascinating example of the intersection of math and real-world applications. But what about the towel's performance in extreme conditions? For instance, how does it hold up in high-temperature environments, such as industrial washers or commercial laundries? Researchers have found that the towel's absorbency can be optimized for high-temperature applications by adjusting the fiber density and arrangement. This means that the towel can maintain its performance even in the most demanding environments. And then there's the issue of durability. How long does the towel retain its absorbency over time? Studies have shown that the towel's absorbency can degrade over time, but this can be mitigated by using specialized materials or manufacturing techniques. By understanding the underlying mathematical patterns and principles governing the towel's absorbency, scientists can design and engineer materials with optimal performance and longevity. So what can we learn from this simple towel? For one, mathematical the patterns and towel's absorbency is principles that govern real complex world phenomena. By harnessing the power of math and science, we can create materials and technologies that transform our daily lives. And it all starts with a simple towel, a ubiquitous object that we often take for granted. But as we've understanding the scene, mathematical the patterns and towel's absorbency is principles that govern real complex world phenomena, governed by intricate mathematical patterns and principles. So the next time you grab a towel, remember the incredible science and math that goes into making it work its magic. Want more mind-blowing facts? Hit subscribe and join our journey of discovery. Thanks for watching, and don't forget to like and comment below with your thoughts on the amazing world of mathematical patterns.